Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems on K-map, and in this video we're going to see three variable K-map for POS method. In previous videos we have seen problems on K-map for SOP method, but this video is about POS method. Before going to this video, I would recommend you people to go back to previous videos where I have explained about basic structure of K-map, what is the rules and regulation that you have to follow for POS and SOP method, so that you can very clearly understand this particular video, right? And we will start this particular video with this particular problem, where the question is simplify the Boolean expression using POS method, and we have to implement that using logic gates, right? First, you have to understand what is POS method. It is completely different from SOP method, right? POS, from the name itself, you can understand it is product of sum, which means you will have some sum, right? And you have to product those sums, correct? Like this, product of sum, right? Another important thing is here 0 is considered as a non-complement form and 1 is considered as a complement form, which is completely opposite than SOP method, right? So with this we will solve this particular problem, whereas first thing what you have to do is you have to find out which K-map I have to use, whether it is 2 variable, 3 variable or 4 variable K-map. By looking at this problem, you can see here it is a 3 variable K-map, right? Because they have given already A, B and C, right? Even if it is not given, you can understand from this particular values. If this value is within 3, then you have to use 2 variable K-map. If it is within 7, we have to use 3 variable K-map. If it is above 7 and within 15, then you have to use 4 variable K-map. Correct? So now this is a 3 variable K-map. So how will you solve this particular problem? So this is A and this is B and C, right? Whereas this will be 0 and 1. This will be 0, 0, 0, 1, 1, 0 and 1, 1. Correct? Now you have to do the positions, which is 0, 1, 2, 3, 4, 5, 6 and 7. And then what you have to do, you have to find out the this variables, right? We know that in POS method, 0 means non-complement form and 1 means complement form, correct? So this will be A and A bar, this will be B, C, whereas this will be B, C bar, whereas this will be B bar, C bar, and this will be B bar, C, just opposite to the SOP method. If it is 1, it is a complement form, correct? And then what is that we have to do? We have to assign 0 for all these values, right? For 0, I'm putting 0 in the 0th position, and 0 in the 3rd position, and 0 in 6th position, and 0 in the 7th position. And all other things I have to put it as 1. This is also just opposite of the SOP method. In SOP method, you will assign 1, whereas here you have to use 0. And now you have to combine, correct? So how will I combine? I'll take this value, these two, right? I have to combine zeros here, right? So if I want to combine these two, what will obtain? Definitely this row alone. So definitely there will be A bar, correct? There will be A bar, right? And this one, right, among these two, we know that it is a product of sum. It is a product of sum, right? So it is A bar, and among these two, what you will do? B bar, C bar, and B bar, C. C and C bar gets cancelled, so you'll have only B bar, right? So you'll write it as sum here, A plus B bar, right? A bar plus B bar, correct? And then you can also take these two, correct? take these two, A and A bar gets cancelled, and you have only B bar, C bar. So the other product is, other sum is B bar plus C bar, correct? Right? And this 0 alone is left alone, and we have to take this, right? So it will be A, B, C, which means A plus B plus C, right? And now this is the answer for this particular problem. And what you have to do, we have to implement using logic gates. How will I implement, right? Same like before, you take this one A, B, and C, right? You can also use this method, or you can also use like A bar, B bar, and C bar. Okay, I'm taking this A, B, and C, which will be very easy. So first thing is A bar and B bar, right? It is summation of A bar and B bar. So what I will take A bar. For A bar, I have to use a NOT gate, right? And then for B bar, I'm using a NOT gate, and there is a summation for it, right? So I'm using a OR gate for it. I'm using a OR gate, right? And then B bar, C bar. So what I will do, I will use a B and a NOT gate for B bar, and similarly for C bar, I will use a NOT gate. And again, it is a summation. So what I'm going to do, I'm going to use a OR gate here. I'm going to use a OR gate here. And now what you will use, the last one is A, B, and C. It is A, B, and C, and again I will use a OR gate because all these are sum. And now all this sum will be a product. So what I will do, I will combine all this thing using a AND gate. This is the implementation using logic gates, right? So now we see the answer here. So you can see here A bar plus B bar. We are getting A bar plus B bar, right? And similarly B bar plus C bar, and then A plus B plus C, correct? And you can see the same thing, same logic gates like this on OR gate, and that will be combined using AND gate, right? So what is this then we have to do? The very important step you got to understand here is this POS is completely opposite of SOP method, right? So which means 0 will be a non-complement form and 1 will be a complement form, right? And you have to put zeros and then you have to combine zeros. So for these two, right? For these two, what is that you're obtaining? You're obtaining A bar B because these two only B bar is common and this one, right? A bar plus B. And for these two, only B bar plus C bar. And for these two, it is A plus B plus C, right? So today what we have seen is we have seen a three variable K-map problem for POS method. I believe this video will be useful for you. Thank you, my dear students.